In this video, we are going to understand what is a file, how many types of files we have in our C language, and how we are going to access these files in C. We are going to understand. So, before entering into the video, we are going to see what exactly a file is. A file is a place. A file is a place where we are going to store the data, where we are going to store the data permanently. It's called as a file. And the data can be stored in the form of records, or it can be stored as a normal data, etc. Okay. So now we understood what exactly a file is. So simply we can say now a file is a place where we are going to store the data is called as a file. And now we are going to understand how many different types of files we have. So we are going to classify the files we have into two types. Number one is a text file, and the second type of file we have as a binary file. So now we'll understand what is a text file and what exactly the binary file is. So the content which is there in the file, which can be understood by the humans. If the data which is there in the file, which we can understand or which we can read it, then we call that sort of files, we call it as your text file. And then coming to your binary files, the content which exists in the file is not readable by the human, and it can be understood only by the computer of that architecture. Then we call those the types of files, we call it as a binary file. An example of a binary file is, so the files which are going to have an extension of .exe, like .obj, .class, and then we have some more examples of binary files which can be called as a video file, the audio file. All these types of files falls into the category of a binary file. Now we are going to see how we are going to access a file. Suppose I say that a file is a place where you are going to store the data. Okay, storing is not only the operation. So now we'll see what are the operations we have in a file. So if I talk about the operations, now we'll talk about the operations which I can do on a file. So the operations which I can do on a file is opening a file, then we have closing a file, and if I want to save the data, or if I want to write the data, then we call this operation as a write operation. And if I want to see the data which is there in the file, we call these operations as a read operation. And if I would like to do some modifications on the data, then we call that operation as read write operation. And sometimes we need to add some data at the end of the file. So when I want to add the data at the end of the file, then we call that operation as appending the file. So these are few operations that we can perform on a file. So for doing all these operations, we are going to have specific functionality in our C language. Suppose, for example, if I would like to open a file, we have a specific function for closing a file, for writing a file, for reading a file, for read writing, and as well as appending. So now, as I said, we are going to have a binary file. We have a file called text file. So for performing the operations on a binary file, we have a different set of operations, and for doing some operations on text file, we have a separate set of operations which can do some operations on the data over the file. Okay. Now, what we'll do is we'll understand how we are going to create a file first by taking a small example. Then we'll see how we are going to save the data into the file. Then we are going to access the data in a sequential manner as well as the random manner to the file. Now, so whenever I want to create a file, so the first and foremost thing we need to do is we need to include a header file called include edio.h. So now this header file is going to contain the functionalities or the structures related to the file handling concepts. Okay. Now, after including this file, then what I do is I'll talk about one more keyword here called file. A file is a predefined structure in stdio where it is used for creating a file pointer, or it is going to take the initiative how we are going to create a file. And without this structure, unless we create a variable of this structure, unless we create a pointer variable of this structure, we cannot perform any sort of operation which can be done on the file. So I would like to create a file pointer. So I'll write my file, then I'll write my FP, where I'll say file pointer. So frequently we are going to use the word called FP, where your FP, it's a variable name by which we can understand what is the purpose of this variable. So the purpose of this variable is to point to the content which is there in the file. So as we said earlier, file is a variable, like it's like a structure, and we need to create a pointer variable for this structure so that I can perform all sort of operations on the file. And whatever the operation which I perform on the file should be done only with respect to our file pointer only. So in this video, what we do is we are going to concentrate only on the random access, because if you understand the concept of a random accessing files, we can easily understand the concept of my sequential file. So before entering into the accessing of the file, so we can access the file. So say we are going to access the files in two ways. Number one is a sequential type of accessing the file, and the second one is a random access files, or we can access the data in a random way. So our language C is going to support both our sequential access as well as the random access. So if you understand how we are going to access the content in a random way, it includes the concepts of my sequential access also. So once you understand how you are going to access, what are the functionalities we have in the random access, it includes the concepts of your sequentials also. So when I talk about the sequential accessing of the file, so if I access the data in a sequential manner, right from top to the bottom in a sequential manner, whereas if I talk about the random accessing things, means for some time I can access the data here, then we can access the data there, we can access the data here, and I can access the data here. It means that we can shift the file pointer within the file according to your requirement, right? So whenever you need a record, I can jump the file pointer from one place to another place. So that can happen only in the random access file. Whereas if I talk about the sequential accessing of the file, it can be done only in the sequential, or it can be done only in an incremental order only. So what we'll do is we are going to understand how we are going to access the content of the file of your C language in a random way. So for doing these things, we are going to understand few functionalities here by which we are going to access the content in a file in a random way. So the first and foremost function we are going to see to access the file is fseek. So fseek is a method which is going to send the file pointer from one place to another place. So, and this is a function which is going to take three arguments. The first argument will be the file pointer, and the second argument of this function is your displacement, and the third argument into this function, I call it as the origin, or some authors say this origin, they will be calling it as your whence value also. So just, okay, now we are going to indicate this as your third argument only. So we know about the first argument which we are going to pass into your fseek, which is a file pointer to your file. Okay, and then about the second argument which is being treated is being sent into the file seek. It can be a positive value, or sometimes it can be a negative value also. So whenever you want to send your file pointer in a positive direction, then we use a positive value there. And if you want to send the file pointer backward, then we use your negative value. So I use my positive value for sending the file pointer in a forward direction. And whenever I want to send your file pointer in a opposite direction or backward, then we are going to use your negative value. Okay, so we'll take an example how we are going to send them into forward direction as well as the backward direction in the further examples. And the third argument which we are going to concentrate, which we have here fseek, is we call it as an origin. So we call it as origin. So this origin can be of three values. We can consider it as three items which we can send there. So the first argument which we have is that the argument can be your seek set. Seek set, and it can be indicated by a value of 0. Okay. Now, whenever I pass this argument, it means that we are going to send your file pointer to the beginning of the file. So whenever you want to send the file pointer to the beginning of the file, then we are going to pass this argument. So whenever you pass this argument as my third value, when I call this method, the second argument will not come into the picture. Okay, so if my seek set is equal to 0, it means that we are going to send the file pointer to the beginning of the file. So I'll say this is beginning. And the second value which I can send into this value is my seek underscore current, CUR, and the value which I indicated as 1. Means that we are going to consider the file pointer where it is. Okay, suppose I say my file pointer is there at the 100th byte in the file. So the file pointer will be pointing to that number only. So when my seek, when my origin or when my whence is seek underscore cursor or current, or the value is equal to 1, then only your displacement value comes into the picture. Suppose I say I'm there, I'll write the program, or I will be calling the method in this way. Suppose I'll say fseek, then I'll say my file pointer, comma, suppose 20, comma 1. Means now what you understand now, it means that suppose I assume that it is my file, and my file pointer is somewhere at my 100th position here. Suppose my file pointer is there at the 100th character or 100th byte of my file. Now I am going to consider the value 1. If I say value 1, it means that my file pointer is going to store the address of this byte in my file pointer. Now, if I say 20, if I send my 20 as an argument, it means that after executing after the successful execution of this function, now your file pointer will be at 120th byte or 120th location in your file. It means that whatever the value which we are going to send as a second argument into this function is added to the value which is there in your file pointer when my seek current or my second argument is equal to 1 or it is my seek current. Sometimes I say, sometimes this, as I said, this value can be a negative value also. Suppose I say this value can be a negative. Suppose I say the value is equal to minus 20. Now, the file pointer will be pointing to 80. It means that now we are going to send your file pointer in a backward direction. So it means that whenever I want to send the pointer to a forward direction, we use a positive value. If I want to send the file point in a backward direction, then we are going to use your negative direction. So this is how we are going to utilize the second argument of my function to send the file pointer from one place to another place, which is going to help you in accessing the data in a random manner. And the third argument which we are going to talk about is seek and. So we are going to have seek underscore and. Or we can also indicate this value by 2. So whenever I pass this value as my third argument into that function, it means that we are going to send the control to the last character or the last character of my file. So now you understood now what are the arguments which we are going to pass into my FC. The first argument will be a file pointer, FP, which is the pointer variable of the structure file. And the second argument will be the displacement, whether we need to move in a forward direction or whether we need to move in a backward direction. And the third argument says about the origin, right? Whether it should start from the beginning, whether I need to go to the back or I need to go in a backward or a forward direction, depending upon the displacement as well as your origin. So this is one function. And along with this function, we are going to use one more function for random access file is your ftel. ftel fp. So now you know the meaning of tel, right? We are going to ask what you say the OS, right? So whenever I'll create or whenever I'm talking about the files, it means that we are interacting with your hardware devices. When you are interacting with your hardware devices, it means that we are going to interact with your OS also. So now you are asking the OS to say where is the file pointer in my file. So whenever you want to know where your file pointer is, then you are going to use your method called ftel, which returns this method or this functionality is going to return an integer value. So this return value I can use as an argument in another function. But for now, we need to understand that, okay, whenever I'll call this method called ftel, it is going to tell me where your file pointer is in the file. And the third and foremost function which we are going to have is rewind. And the file pointer we are going to send it as an argument into this one. So whenever I call my rewind on the file pointer, it means that we are going to send your control or my cursor, or sometimes we call it as your file pointer to the beginning of the file. So whenever you want to send it to the beginning of the file, then we are going to use the method called as my rewind. So these are the three functionalities. The first one is my fseek function, ftel function, and rewind function are used for accessing the data in a random access file. So now we'll see a small example, how we are going to create a file, how we are going to save the data into the file so that I can do some operations on the file. So as I said, we are going to include the file, include the header file stdio.h. Then now we are going to talk about the binary file. So as I said, we are going to create a binary file where we are going to save the data so that the humans cannot understand the data. So if the content which is there in the file cannot be understood by the human, then we call that type of file, I called it as a binary file. And also I gave the examples like your audio files, your video files. Means unless we use an application for it, we cannot understand what the content is there in the file. So that sort of file, we call it as your binary file. So now in this example, we are going to talk about the binary file so that we can easily understand how we can uh, perform the operations on that file. So for doing that, what I do is I'll create a structure of your own. As you all know, it is a user-defined type. Then we are going to have some variables as a part of that structure. So in my example, I gave my 3 variables. Then I started my main method. We know what is the purpose of the main method. So whenever I want to execute this program on the shell of your OS, then we are going to call the method called main. Then we use 2 variables. It depends upon you, right? Whether you can use 1 variable, 2 variable, it's upon you. Then the interesting thing here is that we are going to use a file structure. So as I said in the beginning of this video, I said we are going to use a structure defined in stdio.h, which is a file, and we are supposed to create a pointer variable to this structure. So it is a structure pointer variable. A structure, whenever I say it is a pointer variable, it holds only the address. So whenever I talk about a file pointer, I'm saying that we are going to talk about the address, right? So we are going to deal with addresses. So whenever I deal with addresses, then definitely we need to hold that address. And for holding that address, obviously we need to have your pointer variable. So we are going to have a pointer variable. Now, at this point, we are going to create a structure. So we are going to create a structure variable. So R is a structure variable of it. Yeah. Now, I want to open a file. As I said, one of the operations which I can do on the file is opening a file. So when I want to open a file, then we are going to use the method called fopen. And this fopen method is going to take 2 arguments. The first argument will be treated as the name of the file which I want to create. And the second argument specifies what sort of operation we are going to perform on the file. If I say W, it means we are going to uh, create a new file, create a new file where I can save the data into the file, If my second argument is something related to W in the sense we are going to say it is a writer. So whenever I specify the second operation as a W related options, like we have WB plus WB, when it starts with the W, it means that we are going to create a new file. It means we are requesting your OS to create a new file with a name. And sometimes, suppose I say, if that file exists already, suppose I say in this example, chunk is there already. When this file exists already on the device or on your hard drive, so what your OS is going to do is it is going to eliminate the old file and it is going to create a new file for you. And it is going to, we can do some operations on this file, right? So on the successful execution of this function called fopen, so the OS returns an address corresponding to the file and the address of it is stored into the variable of f variable. So which is, as I said, f is a file pointer again which holds the address. So now we are dealing with the addresses. Now we are not dealing with the file here, but we are dealing with the address of it, right? Now, if it is not null, right? If I am unable to open a file, what we are going to do is we are going to return a value one. Value one if it returns onto the calling function. So if I'm able to create a file, suppose I say I'm able to create a file, then I execute a for loop here where we are going to perform 10 operations, 10 iterations we are going to do. Okay. Then I store some value into my X of my structure. As I said, in my structure, we are going to have three variables, X, Y, Z. But now, for our better understanding, we are going to take only one variable and we are going to store the value of I. So instead of, suppose if you are interested in taking your two variable also, I can write I plus 1 and R dot Z is equal to I into I. Right? So these are means that whatever the structure variable we have, we need to store some value into that structure variable. So now I stored some value into my X, I stored some value into my Y, and also I stored some value into my Z now. Now, after storing the values into the variables of that structure, now I want to write that structure or the data which is there in that structure variable, I would like to copy it into the file. So whenever I want to save the data into the file or whenever I want to write the data into the file, then you are going to use the method called fwrite. Fwrite is a method again where fwrite stands for file writing. So whenever you want to write something into the file, then you are supposed to use a method called file write. Yeah. It is going to take 4 arguments, as you can see. The first argument will be the address of the structure in which you are having the data. So now you are copying some data for every iteration. You are going to manipulate the data in the variable of the structure. So whatever the data, whatever the structure you want to save it into the file, the address should be specified as the first argument. And the second argument will specify the size of the structure, how many bytes you are going to write into the file. Okay, so this size of is an operator which is going to generate how many bytes are occupied by this structure, and the third argument says how many records you want to save it onto the file. Suppose in my example, because I'm having only one structure is there. Because I'm having only one structure, I say I'm having only one record. But in many cases, we are not going to perform the fwrite operation only on one record. But I can gather some 100 records with me. I can have some 100 records with me. And then at once I can save it on the file by changing this value. For now, we are going to take only one value. It means we are going to take only the value which is stored in one structure variable only. Then, and the fourth argument specifies the file pointer, where we are going to save this structure content. So I said we are going to create a structure, we are going to add some value into that structure. So that value is being stored into this defined address or the generated address by your OS. So if I'm able to complete this function or if I'm able to execute this function successfully, it returns a positive value. Okay. When it returns a positive value, then we need to understand that, okay, that whatever the content which is there in my structure is successfully sent into the file. So after writing 10 records into the file, now we are going to use an operation called close operation. Close is an operation by which we are going to save the data into the file and then we are going to close that file. And now if you open that file on the notepad, okay, you can see the content, but the content which is saved in the file seems to be like jumbled. And sometimes we cannot even understand what exactly the data is in the file, because your file is a binary file. So this is how we are going to save the data into your file. So now we'll see how we are going to read the data from the file. So again, whenever you want to read the data from the file, again, we are going to declare the similar structure. So we are going to declare the similar structure which I used for writing the data into the file. Okay. So whatever the variables which are there in that structure should be same as it is by reading the data in the file. It should not mismatch. Okay. So what happens if you mismatch or if you have different variables? It means the number of bytes which are to be occupied by the variables of that structure differs. And if the structure size differs, so there may be a possibility of overlapping of your structure. So for avoiding that overlapping, what we do is that we are going to declare a similar structure, almost the same variables which I have in my previous thing while storing the data into the file. And what I do, again, as I said, we are going to declare your main method, then we are going to open your file and the purpose right now. Earlier our purpose was my write purpose. Now our purpose is to read the data. So whenever I want to read the data, and the second option into my F open will be the read option. Okay, then again we are going to check whether I can open that file or not. Yes, if I can open that file, then you are not going to execute this particular statement, then my control jumps to this state. Here, again, we are going to have an iterative statement, means we are going to execute this particular loop for 10 times. Okay, this loop is been executed for 10 times. Now, our purpose of this program is to read the data from the file. So whenever I want to read the data from the file, then we are going to perform the operation called fread, where your F stands for file read. It is file read. Okay, file read. And then this file read is going to take again 4 arguments. As I said, fwrite is going to take 4 arguments. In the same way, fread also is going to take 4 arguments. And the first argument which we pass here is the address of my structure variable into which I want to copy the data. Means whatever the data which is there in that file, I want to copy into this structure. So we need to specify the address of that structure. And the address I can specify by using a symbol here called ampersand symbol and the name of the variable there. And the second argument will be the size of the structure. So the size of the structure, so in your example, in your last example, we have 3 variables. We have 3 variables. Now we have the structure, right? So we have the structure of that variable. Yeah. Then one, number 1. And the third argument. Third argument will be 1. Means whenever I want to read only one structure, right? Whenever I want to read only one block of data. So this indicates the blocks, right? So this third argument indicates the block, otherwise it indicates the record. Whenever I want to read only one record or one block, then I specify this number. And the fourth argument, which we are going to supply into this function as an argument, is my file pointer, which is the address of my file. So if I am able to execute this function successfully, again, it returns a positive number. So with that number, you can understand that, okay, I'm able to execute this function in a successful manner. Okay, then after feeding the data, now we need to check whether whatever the data fetched from the file into the structure is appropriate or not. Then we are going to print the value by using your output statement. And after doing all those things, now what I do is I just close your file, and then we go to the new line in this function. So these are so this is a very simple functionality by which we are going to read the data from the file. Now we'll see how we are going to access the data from the file in a reverse order. Sometimes we may be having a situation where I want to access the data from the last record to the first record. Now we are going to understand what is the logic we are going to follow. Just we'll see. So again, whenever I want to read the data, we are going to open the file with the read mode. Okay. Then see here. We are going to say seek set. Whenever I say seek set, it means this value will be equal to 0. So when I say it is 0, it means we are going to send the file pointer to the beginning of the file. And when I say seek set, when I say my third argument is seek set, there is no importance for this number called 0. So it can be of any type, right? Now, we'll see how we are going to read the data now. Okay, it is about reading, right? Okay. Now, just to see here now. It is about only reading, not reverse order. Then we'll go for the reverse order. But just we'll see how we are going to read the data. Okay. Now what I do now, just we are going to say seek set is equal to 0. Then we are going to enter into the iterative loop there. And I write ampersand of R, the structure of my record, the size of the record, how many records I want to fetch. I want to fetch only one record and then file pointer. Then we are going to print the content. Okay. Then we are going to print the content on my screen by using this output statement. Now, after reading the data, now what I do is now we are going to call the method called fseek. Okay. Fseek is a method which is going to send the control to the corresponding position, which is indicated by the origin right now. What I do, I want to read the data from the file. I want to specify the structure here now. What is the structure here now? The size of the structure will be the number of variables. Okay. Then I'll say my C current. So from where you are going to read, it means that after reading this, suppose I say this is my file. Okay. So we are having, suppose I say record number 1 I stored, record number 2 I stored, record number 3 I stored, etc. Now after completion of my F read, my file pointer will be at this position. Where it will be, my file pointer will be at this position. Now, from this position, now what I do now, we are going to send the control, okay, fseek f of size of record. It means that from here, I want to skip one record. It means that I want to read the records in an alternative way. So I'll say just I will be skipping. It means I will be saying this is a positive value and from the current. It means that we are going to send the control over here. And then we are going to read the data. It means that now it is a logic, right, uh, by which we are going to read the records of the file in an alternative manner. So whenever you want to read the file in an alternative manner, then we are going to use this simple logic for doing it. Now we'll see how we are going to print the records of the file in a from the end to the beginning. So again, we are going to open the file. As I said, we are going to say whether I'm able to perform these operations in a correct way or not, or whether I'm able to open a file or not. Now we are going to run my iterative loop, right? I is equal to 9 greater than 0, I minus minus. Now we are going to use a method called fseek. Fseek is a method which is going to send or which is going to shift the file pointer from one place to another place. So FC, and the first argument will be your what you say file pointer, and the second argument will be the size of the record, and to I. Suppose I'm having a file. Suppose I'm having the file, and we are going to have the records here now. Suppose I'm storing the records in this way. So because of the space constraint, I'm able to save them, or we are going to show in a smaller thing. But all these things are saved in a sequential manner. They are not being stored in the rows and columns. Okay. Just by seeing these things, don't estimate that, okay, all these things have been saved in this manner. No, no. All these things have been saved on the disk, right? So the space on the disk will be in a sequential manner. So we need to visualize that the content is there in a sequential manner. Now I say the structure of the record. So the structure of the record is 8 bytes. So the structure of the records is 8 bytes. So I 8 into I 9 means 8 into 9 means I'll go to this record. I'll go to this record. Seek set means seek set in the sense now what we are going to understand. Seek set in the sense from the 0. It means now the file pointer is assumed at this point. Okay. From here, we are going to say size of record is 8 into 9. What is this 9? This is from the loop. It means now we are going to send the control to this record to fetch this record. So we are going to fetch this record. After means we are going to send the control here. After sending the control there, now we are going to read the data from the file. And whenever I read the data from the file, now that data will be stored into this variable, and we are going to print the data which is there in that record as an output statement. And then output statement. Now, after I is equal to 9, now the value of my I is going to become 8. Means now the structure of this record, now this is multiplied by 8. 8 and 6 set again. 6 set in the sense again from here, again we are going to send the pointer to the beginning here. And then we are going to send the file pointer to this place, and then we are going to read this structure, and then we are going to copy the data from this structure onto the variable, and then we are going to print. And now I is equal to 7. Then we are going to multiply this 8 with 7. So we are going to shift the file pointer here. Means now this is a simple logic by which we can read the data. We can read the data from the backward direction, from the back to the front. And we can also have another simple technique. I will be explaining you what is the second technique by which we can read the data from the back to the front. So in continuation with the last topic, so we had the content which is used for saving the data into the file, and then we are able to save the content into the file, and we are able to reach out to the specified location of the file. Now, we are going to understand how a specific content or a record in the file can be changed. So we'll see that one now. So now, as you all know that, right, so we are going to open the file using these options, right? Instead of using R, I'll just say R plus, where it will give you the flexibility to do some manipulations or updations in the content which is there in the file. And then again, now, whenever I want to update your fourth record, right? Suppose I say record number 1, 2, 3, 4. So I want to update my fourth record. So whenever I want to update the fourth record, what I need to do is, first of all, we need to send your file pointer to this record. Okay. So whenever I want to send the file pointer to a specific record in the file, as we all know, we are going to use the method fseek, where we are going to pass your first argument, and then we are going to multiply the size, okay, with that number, right? Suppose if I want to update my fourth record, right? So I'll send the control to the end. So the end of the third record, it means that it will be the beginning of your fourth record. So I'll say 3, then we are going to use the option called seek set. Then what I do, I'll just read the content. So whenever you say you are going to read the content, means that content is there with my structure. Then we are going to manipulate that value. And then we are going to set again. See, when I read the data or when I do some manipulations of the data, the file pointer is sent here, isn't it? Isn't it? So again, what we need to do, we need to bring back the file pointer to this position. So to bring back the file pointer to this position again, I use the method again with the same values. Okay. So this function is used for sending the control to the specific location of the file. We are going to modify that content, and then we need to bring back the file pointer to this position again. So for doing it again, we are going to use the same operation, which will send that control to the specific location, and then we are going to save the file onto the file onto save the content onto the file. So this is how we are going to manipulate the content which is there in the file.